Now we'll just have a brief lesson to summarize this module. We'll briefly review the various strategies for the quantitative comparison questions. Of course, by far the most important quote-unquote strategy is to know thoroughly the math content. Nothing can substitute for that. As you practice questions, use the related lesson feature to go back and review content areas about which you are unclear. That is golden. If you think you understand a topic and then a question shows you that you don't really understand it, it's absolutely golden to go back and find out what that missing piece is and to understand more deeply. Don't think in terms of I understand or I don't understand. Always think in terms of level of understanding. How can I understand more deeply? Remember the lesson on approximation from the earlier batch of lessons at the end of the General Math Strategy module. That's very important, especially on the quantitative comparisons. The quantitative comparisons are all about using approximation effectively and intelligently. One huge trap on the quantitative comparisons is getting sucked into detailed calculations. Remember that you shouldn't touch the calculator more than once or twice in a math section, and perhaps not at all on the quantitative comparisons. The quantitative comparison questions are designed to be handled as quick comparisons, not lengthy calculations. So if you're doing long calculations on the quantitative comparisons, as a general rule, you're probably doing something wrong. There's probably a shorter way to go about it. Remember that one way to think about quantitative comparisons is as an unknown relationship between two quantities. You can do anything to both quantities that you would be allowed to do to both sides of an inequality. And so anytime you're thinking about, well, am I allowed to do this operation to both sides? Well, think about whether you'd be allowed to do it to both sides of an inequality. That's the way you know. Remember that picking numbers is a strategy that yields definitive results only about 25% of the time, whenever D is the answer. If D is not the answer, then picking numbers alone is not going to isolate a particular answer. You'll need to use some logic and mathematical thinking. Remember that D cannot possibly be the answer if there are no unknown values. If both things are numbers or things that have definite values that can be calculated, well then, even if it's hard to calculate, D cannot possibly be the answer because there's some value, some fixed value in quantity A and there's some fixed value in quantity B. Remember to be suspicious of geometric diagrams. Some will be completely specified and you simply need to do a calculation, but others will be variable. They will appear one way, but the properties will not be locked in place, and in fact several different geometric shapes will be possible, and really a question like this is testing your ability to imagine different possibilities. Most often when there are many, many different visual possibilities, the answer will be D. Often, not always, but often. You will need to know the familiar algebraic patterns, especially the square of a sum, the square of a difference, and the difference of two squares. We reviewed these a couple lessons ago. These three patterns are very important in the algebraic section. You'll need to know all the integer properties well. There's many things that they could test about integer properties. It's really about the deep mathematical thinking you can do with those definitions. On the quantitative comparison questions, the GRE does not care about your ability to perform long, detailed calculations, and it is not all that interested in your knowledge of formulas. That's not what the quantitative comparison questions are about. On the quantitative comparisons, the GRE is deeply interested in your fundamental logical skills and your ability to engage with mathematical thinking. It focuses on your creative ability to think out of the box and to apprehend ways of framing a comparison that make the relationship clear and easy to understand. That's the really big part of the quantitative comparisons. How do I look at the problem so that the comparison becomes something very easy? That is fundamentally what the GRE is testing over and over again on these questions.